talk about 8.1, the law of sines. This first definition here deals with the concept of an oblique triangle, which of course you've heard of before. So an oblique triangle is any non-right triangle. Any triangle can be turned into two right triangles by dropping an altitude, which is a perpendicular line from one vertex to its opposite side. So it doesn't matter what your triangle looks like. If you've got a triangle that looks like, say, this, for example, amazing triangle, and you just drop an altitude. So an altitude is something like this, a perpendicular from one vertex to its opposite side. So here's a vertex down to its opposite side. Then we have made 90 degrees twice here, and we have turned this oblique triangle into two right triangles, and we can do something with it. That's all that's saying. This second part goes on to talk about types of angle-side relationships. So let's talk about those. So to solve a triangle, we want to find all three sides and all three angles. That's what solving a triangle means. You find all three sides and all three angles. In order to do this, we need three of those pieces of information with at least one side. There are three angle-side relationships that we're going to look at that the law of sines applies to. The first one is angle-side angle, abbreviated ASA, and that's the measurement of two angles and the side between them. So that's something like this. If I have this triangle here, for example, if I knew this angle, I knew the measurement of this side, and I knew the measurement of this angle, then that would be an angle-side angle type situation that we could deal with. The next one is angle-side. So AAS, we know the measurements of two angles and a side not between the known angles. So for example, if I had this triangle right here, and I knew, say, this angle, and this side, that would be angle, side. And then side, angle, which notice we say it that way, not backwards, for a reason. We know the measurements of two sides and an angle not between the known sides. So let's say that we had some sort of situation like this. It's a very bad triangle, but let's imagine it as a triangle. I can draw it a little bit better than that here. Let's do this. There we go. Side angle. So we know this side, and say this angle here. That sort of thing would be enough for us to use law of sines. So ASA, AAS, and SSA are the three situations where we can use the law of sines. For everything else, there's the law of cosines, which we'll get to shortly. Okay. Now, the law of sines is right down below. And it says, by deriving rules from right triangle properties, the law of sines says, given a triangle with angle alpha, opposite side A, angle beta, opposite side B, and angle gamma, opposite side C, that this relationship holds. So let me draw a triangle here, just some oblique triangle. It doesn't have to look exactly like this, but I'm going to make it look like this. Okay? And let me show you how to label this. Angle alpha, opposite side A, means angle alpha, let me do this in different colors. Angle alpha goes here. Okay, and lowercase a represents this side here. That's what opposite means. Okay, let's do another one. Let's do angle beta, opposite side B. I could put beta in either of the two remaining angle slots. I'm going to put it here. Opposite side little b. Okay, and then last, I'll do it in green here. We have angle gamma, which looks like that when you draw it, opposite side C. And that's the relationship that we look at. Now, sometimes you guys may see capital letters used instead of these Greek letters. You may instead see these things in here labeled as just A, big B, and big C. Opposite, that's big C. Opposite, little c. You may see it labeled like that as well. Regardless, the law of sines says that their ratios of any two of those are the same. So the sine of alpha over A is the same thing as the sine of beta over B is the same thing as the sine of gamma over C. And you can read it as this part. So sine alpha over A equals sine beta over B. There's actually three formulas here. You can read it as the sine of beta over B equals the sine of gamma over C. Or you can basically just delete this middle part here, and you can read it as the sine of alpha over A equals the sine of gamma over C, because that's how the transitive property works. All right. For the exact same triangle, it also holds that you can flip each one of these, basically. So you can take each one of these and you can reciprocate them, and A over sine of alpha equals B over sine beta equals C over sine gamma. So really, the whole point of law of sines is you just choose which permutation of the law of sines works for you. You take the three pieces of information that you're given, and you pick the correct version of the law of sines that makes it the easiest for you to solve for the missing variable, and that's it. And once you've done that, it becomes pretty easy to solve the rest of the triangle. So go ahead and get that down, and we're going to move on, and we're going to do 3 little examples, and we'll be done. So in this first example here, it says in triangle GHI, G is 61, angle I is 81 degrees, and angle G is 63 degrees. Solve triangle GHI using the law of sines. You can assume lowercase letters are sides, uppercase letters are angles, and the angles and sides are opposite that of their corresponding cases. When I say case, I mean lowercase and uppercase. So we were given that information, so let's go ahead and draw this thing out. So let's actually draw out a triangle here. And it's always going to be very helpful to draw a triangle. It doesn't matter what the triangle looks like. Just please do yourself a favor and do not draw it as a right triangle. Doesn't matter what you make it look like, just don't make it be a right triangle. And I'll connect these remaining 2 vertices. There, perfect. This might not be to scale. It doesn't matter. As long as it's here, we're good to go. So let's label everything. I know that side little g is 61. Pick one of these things to be 61. This one is 61. So this is G equals 61. I'm going to label that. And I know that angle G is 63 degrees. Well, angle G is opposite little g. That's what it says. Angles and sides are opposite their corresponding case. So lowercase g is here, so uppercase G has to go right here. That's what we're going to do. So uppercase G was 63 degrees. So we know that this is 63 degrees. Okay. Now, we have angle I is 81 degrees. So pick one of these 2 sides to be 81 degrees. Let's say this one is 81 degrees. It looks closer to 81 degrees than the other one, but it doesn't matter. Okay? And then the remaining thing that we know is nothing. So we have to figure out the other 2 sides, this side, and we have to figure out this angle. Now, it's easy enough to figure out this angle. You know that the interior angles of a triangle must add up to be 180 degrees. So then this angle, whatever this angle is, okay, and remember this is triangle, if you want to label it all, this is triangle G H I, if you want to label it. So you know that this is side little I and this is side little h. And I know that that's normally the complex number square root of -1, but for us it's just little I. Who cares? All right, so we know that we're trying to find angle h here. We're trying to find this side I and this side little h. So let's go ahead and do that. So we can find the length of the measure of this angle, rather, is 180 degrees minus 63 degrees minus 81 degrees. Okay. Now, if you take that and you plug that into your calculator, 36. So we're going to go ahead and have 36 here. 36 degrees. And I'm going to keep it in green. That's what we solved for. We know that that's 36 degrees. And now that we have that missing piece of information, we can use the law of sines to relate everything to each other. So I'm going to write out the law of sines for this entire triangle. So remember, this was side H and this was side I, and we use lowercase for the sides. So we can write, either version of this is fine, but we can write I over the sine of big I equals G, or rather little g, over the sine of the angle, big G, equals h over the sine of big H. So the sine is of each of the big guys, and then the sides are on their own. You remember, you always take the sine of an angle, so be plugging in angles to these. So we need to figure out either h or I at this point, either h or I. It doesn't matter which one we figure out right now. It becomes pretty easy to find the other one. So what we're going to do is we're just going to choose one of these. So let's figure out h, for example. So I know that we need h. We have the sine of h. Now I can relate h and I to each other if I want to. The problem is I don't know I either. But I do know the side g. So here's the three pieces of information that I'm going to use. I'm going to say that h over the sine of h equals little g over the sine of big G. The reason that I'm picking that is this. Watch this. I don't know h. That's what we're trying to find. I don't know h. I don't know it. However, I do know big H. It's right there. Okay. I do know big G, or little g rather. It's right there. And I do know big G. It's right there. I know all three other pieces of information. So if I plug all of this in, then I just solve for h, shove it into a calculator, and I'm done, which is exactly what I'm going to do. So I know that h is, big H is who knows. I don't know what side this is, so that's what I don't know. So it'll be h over the sine of, but we know that big H is 36 degrees, so I'm going to write 36 degrees. Equals, I know big G is 61, so I'm going to write 61 over the sine of, and then I know that big G is 63 degrees, so I'm going to write 63 degrees. And now I'm going to take this guy and I'm going to solve it for h. I'm just going to multiply both sides by the sine of 36 degrees. So I'm going to get that h is 61 times the sine of 36 degrees over the sine of 63 degrees. Okay? Now, how do you know what these things are? You don't. You plug it into a calculator. 61 times sine 36 degrees over sine of 63 degrees. And make sure when you do plug it into a calculator that you're in degrees and not radians. However, when you plug this into a calculator, you get about 40.24. If you want to round this, you get about 40.24 degrees. Now, notice that up here it doesn't actually say anything about rounding anywhere up there. So, honestly, you could probably get away with writing that as 40 degrees, since what you have, rather, not 40.24 degrees, you get 40.24. So it doesn't say anything up there about rounding to anything, but you were given G as just straight 61. You may be able to get away with just 40. But 2 degrees is usually good enough in here. So you get 40.24 is the length of this side. 40.24. Awesome. Now, the only thing that remains to do is to get rid of this stuff here in this box, and let's set up and do I. Let's figure out I using the information that we already have. So to find little I, this side here, let's set up this part here that we know. So I actually need to introduce little I over sine I, that ratio, sine of big I. And then I can pick either this part or this part. It doesn't matter. Since we know both parts of little g and big G, and we know both parts little h and big H, we can pick either part we want to. The thing is that G is an easier number than H. So in general, you want to go with information that was given to you in the problem. And we already know that, so let's just go with that instead. Because we had to find both H and big H, the angle. So let's go with the stuff that was given to us in the problem. That's going to be a little bit easier on us. So let's relate this to G over the sine of big G. Plug everything in and you're done. Now, I used the version of the law of sines where the sines were on the bottom, because what I'm solving for is a side. If I were solving for an angle using the law of sines, then I would have used the other version where the sines are on top and the sides are on the bottom. Regardless, just plug everything in and that's it. So little I over the sine of big I was 81 degrees, equals G, which is 61, over the sine of big G, which was right here, 63 degrees. And yet again, we just solve. So I equals, multiply both sides by the sine of 81. And you have 61 times the sine of 81 degrees over the sine of 63 degrees. Now, if you've done this at this point, you probably still have that last thing sitting there in your calculator. And you'll notice that when you use a form that looks like this and you're solving for a side, you keep getting this sort of thing over again. Something times the sine of something over the sine of something else. So all you have to do is go back and just delete the parts of this that are different and plug in new numbers, and you'll get the answer for this part again, and you save yourself some work that way. In this case, you only need to change the one number. This guy on top needs to be changed from what it was into an 81, and you'll get that it is about 67.62. And it's a little side. It's a side, so there's no need to put a degree. No need to put a degree there. So just equals 67.62. And now we know all the angles. We know all the sides. We've completely solved this triangle. Now, there's some checks that you can put on this, that you can look at this triangle and you know that you solved it, or you know that it at least makes sense. So I want you to look at this really quick, and I'll do it in this red here. The smallest angle was 36 degrees. Opposite it was the smallest side, 40.24. The largest angle was 81 degrees, and opposite it was the largest side, 67.62. The middle angle had the middle side measurement in between them. It should always work out like that. If you ever get it any other way, that's a really quick check that you probably didn't do something right. All right, moving on. All right, let's talk about example 2 here. In triangle LMN, let's go ahead and slap that down. Let's draw it however I feel like it. Let's draw it like, I don't know, this. I like to vary this up. All right? So in triangle LMN, okay, we have that little l, so that's opposite side big L, so this side over here. So little l is 570. Okay. Angle M is 84 degrees. Okay. And big M, or little m rather, is 820 degrees. So that's 820 degrees. Or 820 rather. So we're asked to solve for the remaining parts. We want angle L in degrees, angle N in degrees, and side little n, whatever that is. So the trick with law of cosines is, first off, figure out which angle side relationship we have. So right now, we're going to be working off M, the M's. That's the relationship that we have. So let's relate those. Now, let's figure out what it is that we want to solve for. So the first thing I'm going to write down is this. I'm going to write down that the sine of 84 degrees over M, which is 820. That's the relationship that we knew. We knew that the sine of big M over little m, that ratio is what we're going to equate with. Now we're going to say this equals, and we're going to try to use this remaining piece of information. The L is 570. So that was a side. Since the side went on the bottom over here, it goes on the bottom over here too. And since this was little l, then what we're talking about up here is the sine of big L. So I guess we're solving for big L. So let's solve for big L. So you get that big L equals, I'm going to multiply both sides by 570. So you're going to get 570 times the sine of 84 degrees over 820. But not just big L, the sine of big L. Keep that in mind. Okay? The sine of big L equals all that garbage. Well, if you run that into a calculator, which is absolutely what you should do, you get back about 0.69. So this is about 0.69. Okay? Now, right now, that's kind of meaningless. 0.69. So that's 69 over 100 is the ratio. You have that the sine of L is 0.69. Please do not go in here and write down 0.69. You didn't find L. You found the sine of L. In order to find just L, what we have right now is that the sine of L equals 0.69. In order to solve for that, we need to take the inverse sine of both sides. We're trying to get L by itself, and right now it has sine unto it. So we're going to take the arc sine of both sides, or the inverse sine. So L is going to be the inverse sine of 0.69. And remember that this input to an inverse sine or cosine function had better be between -1 and 1. It better be a proper fraction. All right? So the inverse sine of 0.69 is something else you can type into a calculator. And when you do that, you're going to get, and it depends on what mode you're in. If you get back an answer that's 0.76, that's probably in radians. You should probably convert that to degrees. And if you don't remember how to do that, you multiply by pi over 180. But if you multiply by pi over 180, or you just are smart and have it in degrees to start with, you're going to get 43.63 degrees. Of course, big L is an angle, so it should be in degrees. 43.63. So now we have that, so we plug it in. 43.63. Okay? Now, we could set up the exact same thing to get n. But why would you do that? We know what n is. How do we know what n is? Well, if we know that the value of L is 43.63, then all we have to do is plug that in real quick. So 43.63, okay, like that. We know that this must be 180 minus this minus this. That's easy. So we know that angle n equals 180 degrees minus the 43.63 degrees that we have, 43.63 degrees that we have, minus the other 84 degrees that we have. We could set up another law of sines, but like, why? So you just do this math, and you'll get 52.37. So 52.37. And it's about 52.37. So put it over here, 52.37. It was an angle, so it's degrees. And now that you have that, the only thing that remains is, well, what was n? Okay, so now we want to find n. Since we want to find the side n, let's use the version that has the sign n already on the top so that we don't have to solve for it any other way. Let's make it as easy as ourselves. So n is related to the sine of its corresponding angle. The same way that, now, we have the relationship between m and little m and L and little l. We can use either pair of those we want to. The better one to use is the one that was given to you. It's more exact, it wasn't rounded, nothing was weird about it. So I'm going to use m again. So I'm going to put little m up top, because we used the side over here, so we use the side over here, over its sine. So the sine of big M, which was 84 degrees. But we knew what m was, it's 820, so let's plug that in. So it's 820 over the sine of 84 degrees. Now, this is very easy. You just say n equals 820 times the sine of 52.37 degrees over the sine of 84 degrees. Like that. I just multiplied both sides by the sine of 52.37. It canceled on the left. And on the right, it's up top because I multiplied by sine of 52.37 over 1. And then you just type this bad boy into a calculator, and you get an answer. So something around 652.993. So it's about, 652.993. That's 653. It's 652.99, but that rounds up to 653. So 653.00 if you want to show me that you rounded. 653. Okay? That's it. You've solved the triangle. You know all three sides. You know all three angles. You're done. The interior angles will add up to 180 like they're supposed to. And you can do your little check again. The smallest angle was 43, and the smallest side was 570. The largest angle was 84, and the largest side was 820, and then the middle ones correspond just fine. So you know that maybe the math isn't dead right, but you do know that at least your answers make some semblance of sense. We got old Stu here, old triangle Stu, and let's put triangle Stu here. So let's do an upside down Stu, like this. Okay, so in triangle STU, like this, let's label everything. So little s must be over here, so little s must be 26, okay? Angle S was 119 degrees. And T, little t, which must be right here, opposite big T, must be 14. Okay? Which makes this little u. We don't know what that is. And then, of course, this is angle T, and this is angle U. So we want to solve for everything else, and that's the whole problem. So the very first piece of information that we're probably going to have to solve for, well, let's just see. We have the relationship of S to S, so we're going to have to write that down. Let's go ahead and write that down. And we know that we're probably going to have to involve this T somehow. So we're probably going to have to solve for its corresponding part as well. So since we're solving for an angle, let's put the angle part on top. That's just going to make it easier. So sine of big T over little t, which was 14, okay, equals. And then it's the sine was on top over here, so the sine has to be on top over here. So it's the sine of, and then the relationship was 119 degrees is to 26. Like that. You know that this is set up fine. Now, you could flip both of these. You could write this side as 14 over sine big T, and this side is 26 over sine 119, and you're fine. And you can solve for it just the same as you want to. But why would you start with this in the denominator if you can avoid it? I see no reason to do that. So we say that the sine of t, and remember, we're trying to solve for t, so we're going to have to take the arc sine of both sides at some point. So the sine of t is multiply both sides by 14, so it's 14 sine 119 degrees over 26. And we get that that's something. So we shove that bad boy into a calculator. So when we do that, we get about 0.47. So about 0.47. Now, remember, what we found is that the sine of t is about, well, it's about 0.47. Okay, we found that the sine of t is about 0.47. We're trying to actually find just angle t. So we found the sine of t. That's the ratio. That doesn't help us at all. Instead, let's take the inverse sine of both sides in order to find t. So t is then going to be the inverse sine of 0.47. And we know that this is going to work out. So the inverse sine of 0.47. By the way, since you're probably still going to have 0.47 in your calculator, there's actually an answer button on Delta Math. If you want to hit the inverse sine button, and if you want to plug in inverse sine, and then type in A and S, or hit the answer button, and then press enter, it'll actually give you the answer, and you don't have to type in that decimal, and it'll be even more accurate because it'll use the whole thing, if you want to. You can also just wrap this entire thing up here in parentheses, and take the inverse sine of that, and it'll give you an answer that's even more accurate. Completely up to you how you do it. Doesn't matter. Point is that we do the inverse sine of 0.47 and get something to the effect of 28.1 degrees in degrees. So it's about 28.1 degrees. So we know then that t is about 28.1 degrees. Now, we can find angle U, no big deal. And indeed, we need angle U because we need angle U to relate it to little u up here, the side. So we can find that using the law of sines if we want to, right? So remember 28.1 degrees. Well, I'll go ahead and erase all this. Remember 28.1 degrees. So we knew that that was 28.1 degrees. But we know that angle U is just 180 degrees minus 119 degrees minus 28.1 degrees. So if we go through and we do that, then we can do that 180 minus 119, if you want to do this in your head, is 61. 61 degrees minus 28.1 degrees. Okay. And then you go ahead and do the 61 minus 28, and then minus the 0.1. So it's going to be something 0.9. So that's something like 32.9. So 32.9 degrees. And we're going to write that up right here. So this is 32.9 degrees. And now we just need to find little u, the side, little u. So let's do that. The side, little u. So we want to find the sine, little u. So let's put the little u on top. Over the sine of its corresponding angle, big U, which was 32.9. We just found it. Okay. That's going to equal, and then you can relate either little t to big T or little s to big S. It doesn't matter which one you do. However, you were given little s and big S in the problem, and you didn't have to approximate them, so that's probably the better choice. So little s was 26, and remember the side went on top over here, so it goes over top over here, and on the bottom is the sine of 119 degrees. So then u is going to be 26 times the sine of 32.9. I just multiplied both sides by the sine of 32.9 because that's how you get rid of a denominator, over the sine of 119 degrees. And when you do the math, you get that that is about 16.15 if you're rounding. So about 16.15. And I'll write that up there, 16.15. Always write it back on your triangle. And you're done. How are we done? We have all three angles and all three sides. All right, so I wish you all luck in these, and I'll see you back in 8.2.